All right. I have muted you people for now. I'll unmute you in case you have any doubt later. Okay. So in the last class, we just began functions and relations. So let's quickly look at that. Yeah. Okay. A function is an object that sets up an input-output relationship. You all know this already. A function takes an input and produces an output. The same input always produces the same output. um, Function is represented as f of a equal to b. The function is also called a mapping. That is f of a equal to b. If f of a equal to b, then it means f maps a to b. And we also already know what is the domain and range of a function. Domain is the set of possible inputs to a function. Range is the set of possible outputs of the function. To represent a function f with domain D, and range R, we write either like this or like this. So let's look at an example. So let's take a function where f of n equal to n plus 1 mod 5. So n can take, so let's assume n takes 5 values, 0, 1, 2, 3, 4. Then f of n will be, f of 0 will be 0 plus 1 mod 5, that is 1 mod 5. 1 mod 5 is nothing but 1. And f of 1 is 1 plus 1, 2 mod 5, that is nothing but 2. F of 2 is 3 mod 5, that is nothing but 3. F of 3 is 4 mod 5, that is 4. F of 4 is 5 mod 5. 5 mod 5 is 0. Okay. So we can write it like this, or we can write it as f of 0 is 1, f of 1 is 2, f of 2 is 3, f of 3 is 4, and f of 4 is 0. So these are two ways of representing a function, two methods. So this is one method, this is second method. So we can either represent it as a table, or we can represent individual inputs and outputs as mapping. Okay, like f of a particular input is a particular output, and so on. We can call this particular set 0 to 4 as Z5. Zm usually means the reminders when a number is divided by m. Okay, so when a number is divided by m, the reminders range from 0 to m minus 1. So Z5 means the when a number is divided by 5, the reminders range from 0 to 4. Okay. So this particular function f, it is a mapping from Z5 to Z5, right? Here the domain is Z5 and the range is also Z5. The set is same. It's just that the mapping between the elements is different. All right. So this is one example. And then let's look at another example. This is a game which all of you know, stone, paper, scissors. Right. So here there is a mapping, not between these items. I'll tell you what the mapping is, but there is a relation. Scissors beats paper, paper beats stone, and stone beats scissors. All right. Now the same thing can be represented again. Yeah, there was some network issue. I hope you can see my screen and hear me. Let me know in case you have any issue in the chat box. Okay. So in the table format, we can write it as paper, scissors, stone, and the column and the rows both are same, columns and rows. Okay, so now what we want to say is we take every pair of paper, stone, paper, scissors, scissors, stone, and so on, and we check whether the beads relation, like stone beats scissors, is it true or not, or scissors beats stone, is it true or not. So every direction we take, and we will see whether each relation is true or not. So does paper beat paper? No. So here it is false. Does paper beat scissors? No. So that is false. Does paper beat stone? Yes. So that is true. Scissors beats paper? True. Scissors beats scissors? False. Scissors beats stone? False. Stone beats paper? False. Stone beats scissors? True. Stone beats stone? False. Okay. So there are only three states which are true, and that is represented in this diagram. Okay. Now these nine different scenarios, we can also represent it as a list, right? So how do we do that? So here, so either we can represent this function like this, or we can represent it as a list. Beads, paper, paper, false, paper, scissors, false, paper, stone, true, and so on. Okay, beads. So let me write one more. Beads, scissors, paper, false. Okay, so you will get 9 items here in this list. All right, so there are two ways of representing this function. Fine. And if we assume two sets, that is A is paper, scissors, and stone, and B is true or false, then this beads function can be represented as A cross A mapping to B, right? So here, this is the function, this is the domain, and this is the range. All right. Oh, you're unable to see what I'm writing. Okay, just a minute. Are you able to see now? Mention in the chart. Yeah. Okay. So again, I'll just quickly repeat. So this is a game which we know, and we know the relationship between these three items. We know paper beats stone, stone beats scissors, and scissors beats paper. Any other relation does not hold. So we can represent this game. Basically, this is a function. We can represent in table format like this. Both in rows and columns, we have the same items. Paper beats paper is false. Paper beats scissors is false. Paper beats stone is true. Scissors beats paper is true. Scissors beats scissors is false, and so on. So we can fill the table with true false values like this. So either we can represent this function in table format, or we can represent it like a list, right? So beats takes two inputs, paper, paper. Paper beats paper is false, and paper beats scissors is false, but paper beats stone is true, and so on. So we can write it like this also. Okay. So this there are two sets. One is paper, scissors, stone, and another is true or false. The domain is A cross A because you have pairs, right? It's not just P mapping to something. It is P comma P mapping to something, P comma S, P comma scissors mapping to something, paper comma stone mapping to something. So these are pairs which are being taken as arguments. So domain is A cross A, right? And they are mapping to either true or false. So the range is only true false set. All right. So Beats function maps from A cross A to B. Okay. All right. So let's move on. A function with k arguments is called a k-array function. Okay. So in this case, this is a function with two arguments. All right. So this is called a two-array or a binary function. In the previous case, this is a function with only one argument, right? It's like f of n, f of 0 is 1, f of 1 is 2, and so on. So here there is only one argument, 0, 1, 2, 3, 4, only one argument each time. So this function is an example of a one array or a unary function. Okay. All right. A function with k arguments is called a k-array function. The input is a k tuple a1, a2, and so on up to ak. That is the sequence of arguments to the function. All right. So now let's look at properties and relations. A property is also called a predicate. A predicate is a unary function whose range is true or false. Okay. So A predicate is also a function, but two conditions need to be satisfied. One is it should be a unary function. That is, it should take only one argument. Second thing is its range should be true or false. Okay. So in this example, this is a unary function. Yes, it's taking only one argument at a time, but its range is not true or false. Its range is again the same set of numbers 1, 2, 3, 4, 0. Okay. So although it is a unary function, it is not satisfying the second condition. That is, its range should be true or false, which it is not satisfying. So this is not a predicate. If you look at the second example, in this case, the range is true or false, right? Here, the range is B. B is true or false, but this is not a unary function. It is taking two arguments, PP, PSC, PST, and so on. If it is taking only one argument like P or SC or ST, then it would have been a unary function, and the range is anyway true or false, then it would have been a predicate. But here, the second condition is being satisfied, but the first one is not being satisfied. So this is also not a predicate. Okay. So both the conditions need to be satisfied. One is it should be a unary function. It should take only one argument. Second is it should map to only true or false values, no other value. So a simple example is like say even of x. So this function, this is a predicate. Which tells us whether x is even or not. So if you take an example like, okay, is 5 even? No. So the output is false. It is mapping to false. Is 10 even? Yes. So output is true. Okay. So now you see both the conditions are satisfied. There is only one input and the output is true or false only, nothing else. So this is a predicate. All right. This is a unary function whose range is true or false. So this is a predicate. Okay. Now, what is a relation? A predicate whose domain is a set of k tuples like A cross A cross A, so on, k times, is called a relation. That is a k-array relation. Okay. In other words, a relation is a k-array function which maps to true or false, where k is greater than 1. Okay. So the only difference between the predicate and a relation is a relation is also a function whose range is true or false, but it is not a unary function. It has to have minimum 2 arguments. It should have 2 or more arguments. Okay, so to summarize, say a function uh, whose range is true or false, that is called a predicate if k equal to 1. So here I can say a k-array function. Okay, k-array function whose range is true or false, it is called a predicate if k equal to 1. It is called a relation if k is greater than 1. All right, so that is the only difference. Okay, now a simple way of understanding this is sorry, you see, in real life, when we deal with objects, when we try to describe one object, okay, say when you try to describe some particular object like whatever, some x, you can describe various things about that object like, okay, it is white, uh, it is round, and maybe it is big, right? So here in this case, all these attributes, they are attributes of one single object. They describe one single object and they necessarily deal with only one object. So when you say something is white, you are saying only that one thing is white. Okay, so in these cases, uh, these kind of predicates will be true, like white of x. This is true, but suppose you take some other object y, that may not be white, so white of y may be false. Okay, similarly, round of x may be true, some other object y may not be round, that may be false, and so on, right? So here this is a property, and this property, this object is satisfying this property, hence it is true. Some other object may not satisfy this property, hence this predicate is false. Okay, so if you take an object like y, maybe it is not white, maybe it is black, and maybe it is not round, maybe it is of square shape, and maybe it is not big, maybe it is small. So in this case, black of y is true, whereas black of x is false, and so on. Okay, so we have real life examples where we describe an object's properties with only one argument. Okay, so we can mathematically try to capture the properties of an object as predicates, which are functions with only one argument. So each one of these is a function. So white of x, so white is a function which takes an object and sees whether that object is white or not. If that object is white, then this function returns true, otherwise this function returns false. Okay, so each property here can be represented as a function which takes this particular object as input and returns true or false. So that's how predicates work. Relation, as you know, relation is always not with respect to one object. Relation is always between two or more objects. Okay, that is why a relation cannot be a unary function. A relation should be more than a unary function. It should be binary, ternary, and so on. It should have minimum 2 arguments or more. Okay, so in this case, suppose if you take these two objects x and y, suppose I say they have a relation like next to, like x is next to y. Okay, So in this case, we write like next to x comma y. This is true. I may take some other object x comma z. This may be false. Okay, so that is the idea. So here you see relation is always between two objects. If you take this next to kind of a relationship, it cannot be applied to only one object. You cannot say x is next to. No, that is an incomplete statement. X is next to what? That question will come, right? Because next to is a relation. So it needs minimum two objects. But you can say x is white. That's it. It's complete. So you only need x to complete the statement. X is white. That's all. You don't need further a second object. All right. So that is the difference, simple difference between the predicate and the relation. Predicate is a function whose range is true or false, but it is a unary function. Relation is also a function whose range is true or false, but relation is not a unary function. It is binary or more. Okay. That's all. That's the simple difference between predicate and relation. All right. So in other words, a relation is a k-ary function which maps to true or false where k is greater than 1. And a relation with two arguments is said to be a two-ary relation or a binary relation. If R is a binary relation, then the statement A or B means A or B equal to true. Okay. So if A or B equal to true, then we can just write A or B. We need not explicitly write equal to true every time. So for instance, I can say 5 greater than 3. We know this. We write 5 greater than 3 casually. Okay. But technically, this is equivalent to 5 greater than 3 equal to true. All right. So this part becomes optional. That's all. This is A, this is R, and this is B. All right. This portion is optional. Okay. Similarly, if R is a k-ary relation, then the statement R of A1, A2, and so on up to AK means R of A1, A2, sorry, up to AK equal to true. All right. So here also we can say ARB means ARB equal to true, or R of A comma B equal to true. Okay, or just R of A comma B. We can write like this as well. Okay. Now let's take an example. Uh, let R be greater than relation or GT. So we'll just refer to greater than as GT. Okay. And we know that we know all these things, right? 5 is greater than 3, 20 is greater than 7, 32 is greater than 31, and so on. Okay. So if we take a set of ordered pairs of natural numbers, it maps onto the set of true false as below. So let's take all possible ordered pairs: 1 1, 1 2, 1 3, and so on, 2 1, 2 2, 2 3, and so on. Somewhere we may reach some other pair: 1007, 268, and so on, right? Now this is a set of all ordered pairs of natural numbers. Okay, we can now think of a range set which has only two values, true or false. Now if you take, so here the relation is greater than. Okay, now if you take any pair from this set, does it satisfy this relation or not? If it does not satisfy, it maps to false. Is 1 greater than 1? No. So it maps to false. Is 1 greater than 2? No. So this also maps to false. Is 1 greater than 3? No. Is 2 greater than 1? Yes. So this maps to true. Okay. Is 2 greater than 2? No. So this maps to false. 2 greater than 3? False. Is 1007 greater than 268? True. So this maps to true. Okay. So this greater than relation can be thought of as a mapping between every possible ordered pair of natural numbers and true false set. Okay, you take any pair of natural numbers, it maps to either true or false. That's all. So depending on this mapping, this greater than relation is defined. Okay, so rather than drawing this Venn diagram kind of a thing and representing it like this every time, and rather than showing always whether every pair maps to true or false, we can simplify this further and represent greater than relation as a set of ordered pairs which are only true, like 2 1, 3 1, 3 2. Only these pairs satisfy this relation. Then 4 1, 4 2, 4 3, and so on. And somewhere this pair will also come, 1007, 268, right? So here every pair satisfies this relation. 2 is greater than 1, 3 is greater than 1, 3 is greater than 2, 4 is greater than 1, 4 is greater than 2, and so on. So only those pairs which satisfy this relation are represented in the set which is named by this relation. Okay, so this is one way of representing the relation. So if you take all the other pairs like 1 1, 1 2, 2 2, 2 3, and so on, they do not satisfy this relation. Okay, so they do not belong to this set. All right, so a relation R can be represented as a set of tuples that is R equal to x1 y1, x2 y2, and so on up to xm ym, where for I from 1 to m, xi or yi or xi or yi equal to true. Like I mentioned earlier, both these are same. You can either just say xi or yi, or you can explicitly say xi or yi equal to true. That is the idea. Okay, so let's take the previous example, beats example. So let me copy the table. Yeah. So in this example, only these three are true values, right? So we can just say so here beats is a two-ary function whose range is true or false. Hence, beats is a relation and can be represented as beats equal to. So only those pairs whose values are true, those pairs you can put in this set. Paper, stone, scissors, paper, and stone, scissors. That's it. The remaining 6 pairs, they are false. So if they are not put in this list, it is understood that they are false. Only those pairs which are put in this list, it is understood that they are true and that it means they satisfy this relation. Okay. So that is a simple way of capturing a relation. So let's look at one more example and then stop. Small example. So let A equal to 0, 1 and B equal to 1, 2. Okay. Then less than relation, we all know. Okay. So this relation among these two sets, if I have to understand among these two sets how the less than relation holds. Okay. So basically you need to cross these two sets. You will get 4 pairs, right? 0, 1, 0, 2, 1, 1, 1, 2. Among those 4 pairs, which pairs satisfy this relation? 3 pairs satisfy this relation. That is 0, 1, 0, 2, and 1, 2. So 1, 1 does not satisfy this relation. So that need not be shown in this set. Okay. So this can be understood as 0 less than 1, 0 less than 2, and 1 less than 2. So this is nothing but 0 or 1, 0 or 2, and 1 or 2. Okay. Where R is nothing but less than relation. Okay. And the definition of this less than, what is its domain and range? Its domain is A cross B because it's a pair, right? Input is a pair and output is true false set. Right? So, okay, but a binary function like addition is not a relation. Why? Why is it not a relation? Since its range is not true or false. Right? Addition is what? It takes two numbers and returns a number like 2 plus 3 equal to 5. Okay. It doesn't map the input two numbers to true or false, right? 2 plus 3 equal to true or 2 plus 3 equal to false. That doesn't make sense, right? Output is a number, not true or false. So this function, which is addition, it's just a function. It is not a relation because it is not mapping to true or false. All right. So its definition is like this. Its domain is cross product of natural numbers set with itself, like 2 comma 3, 3 comma 4, whatever. and output is again a number. So range is again natural number set. Fine. So here, this is the function, and this is the domain, and this is the range. All right. And we all know usually how we write plus, we write it inside both the numbers, both the arguments. So this is known as infix notation. But technically, this is actually equivalent to this notation, because plus is nothing but a function, right? It takes two arguments and maps it to an output. So this is prefix notation. Okay, so that's it. So let's stop here for today. We'll continue in the next class. Let me take attendance.